In order to solve quadratic equations by using factorization method, we always compare the given quadratic equation with quadratic equation in standard form. So for step 1, comparing given equation in with ax square plus bx plus c, which is quadratic equation in standard form. So here we compare coefficients of x square. Here coefficient of x square is equal to 1, therefore a is equal to 1, and comparing coefficients of x including the sign, don't forget the sign, b is equal to plus 7 and c is equal to plus 12. And for this step we will be finding the value for AC. This is also called AC method of factorization. So the product AC, now find product AC, which is equal to 1 times 12, and this is equal to plus 12. Depending upon the product, if the product AC is equal to positive, then we will find two such factors of the product AC, I mean plus 12, whose sum is equal to B. So let's do that. And two such factors of 12, we can use small division, but obviously for this one the factors are 3 and 4, that is pretty obvious. But we can use the small division for bigger numbers. 12 divided by 2, and this will be 6, and we divide again this by 2, this will be 3, and here 2 times 2 is 4, and 4 and 3, which are obviously factors of 12, these 12 can be written as 3 times 4, that's why 3 and 4 are factors. It can also be written as 2 times 6, but 2 and 6 don't add up to plus 7, which is B. That's why we don't need this one. We just need this one. Again, we have 1 and 12 as factors, but they don't add up to 7. That's why we don't want those. We only need 3 and 4 whose sum is equal to plus 7, the value of B. Therefore, for step 2, once we have found which two factors of the product AC add up to B, then we write x square, which is the equation x square plus, instead of writing 7, we write 3 plus 4 times x, and then plus 12 equal to 0. See, we did not change anything other than just writing the given equation in the form of, instead of writing 7, we wrote 3 plus 4, which were the factors of the product AC. Therefore, x square plus 3x plus 4x plus 12 equal to 0, and now we will group this together. The first two terms will be grouped together, 3x, and last two terms will be grouped together again. Those will be 4x plus 12, and out of these groups we can take common x from the first group, leaving inside x plus 3, and we can take common 4 here, leaving inside x plus 3. This is a checkpoint. This x plus 3 and x plus 3 both must be same. Both group must have the same inside number if you were doing everything all right. And now let's take common x plus 3. that will give us x plus 4 times x plus 3 equal to 0. Now we will be using zero product property of real numbers, which means that product of two real numbers is equal to 0 only if one of them is at least equal to 0. So this means either x plus 4 is equal to 0 or x plus 3 is equal to 0. This gives us x equal to minus 4 and this gives us x equal to minus 3. We can verify the given quadratic equation by substituting the value of minus 4 each time. If we want to verify the solution was x squared plus 7x plus 12, and this must be equal to 0 because that was the given equation. At x equal to minus 4, this would be minus 4 squared plus 7 times minus 4 plus 12 equal to 0. This should give us 16 minus 28 plus 12 equal to 0, and this gives us 28 minus 28 equal to 0. This is 0 equal to 0. Therefore, this solution is verified, and similarly we can verify the other solution as well, which is minus 3 square plus 7 times minus 3 plus 12 equal to 0. It must be equal to 0. So this would be 9 minus 21 plus 12 equal to 0. And you can see that this is 9 plus 12 is 21 minus 21 equal to 0, means 0 equal to 0. So this is how we can factorize a given. We use factorization to find solutions for the given quadratic equation. Let's do another question, and this time we have example number 2, and for example number 2 we have 9x squared. This time given equation is 9x squared minus 12x minus 5 equal to 0. This time a is equal to 9, b is equal to minus 12, and c is equal to minus 5. Of course, we compared 9x squared minus 12x minus 5 equal to 0 with standard form ax squared plus bx plus c equal to 0, and that's how we got the values for a, b, and c. As ac this time is equal to negative number because 9 times minus 5 is equal to minus 45. So now we will be finding factors of 45 whose difference is equal to 12. This is very important difference that you should remember. Whenever AC, the product, is positive, we should find two such factors whose sum is equal to middle number b. And whenever AC is negative, we find two such factors whose difference is equal to 12. So let's find out two such factors of 45 by doing the small division, and this is equal to 3 1 time and 5 time, 15 and 3 5 times. So this is 9 and 5. So 45 is equal to either it is 9 times 5, which means that 9 and 5 are factors, but their difference is not equal to 12, so we can take this one. But there is another one, and that is equal to, if we 3 times 15, 3 times 15, and look, their difference is equal to 12. Therefore, without changing the given equation was So 9x square minus 12x minus 5 equal to 0. This time this will become 9x square minus, instead of writing 12, we will just write it as 15 minus 3. We don't change the value, we just change the way we write 12. Minus 5 equal to 0. And now if we take the simplification, minus 15x and negative time negative plus 3x minus 5 equal to 0. If we take common, here we can take common 3x, leaving inside 3x minus 5, and we take common 1. If there is nothing else common, this will give us 3x minus 5 equal to 0, and we got 3x minus 5 in both terms, therefore we are doing everything all right. 3x plus 1 time 3x minus 5 equal to 0. This means either 3x plus 1 is equal to 0 or 3x minus 5 is equal to 0. So this gives us x equal to minus 1 over 3, or from this part x is equal to 5 over 3. We can verify the solution same way we just did in question number 1, and we'll leave it up to you to verify just like question number 1. And now we'll do one more question, and this time the given question is 1 over x plus 1. Given equation is 1 over x plus 1 plus 2 over x plus 2 plus 2 over x plus 2 equal to 7 over x plus 5. 7 over x plus 5. Now obviously this equation doesn't seem like it is a quadratic equation, but let's simplify and then we'll see what equation do we get. Okay, we'll take LCM on left hand side, which is x plus 1 times x plus 2, and one time it will be x plus 2, that is just a cross multiplication. So this is how we simplify, plus 2 times x plus 1, and then on the other side this is 7 over x plus 5, and here this will become x plus 2 plus 2x plus 2 over x square plus 3x plus 2 equal to 7 over x plus 5. So now let's simplify. On the left hand side this will give us 3x plus 4, 3x plus 4 over x square plus 3x plus 2, which is equal to 7 over x plus 2. 7 over x plus 2. Now we'll do the cross multiplication. Cross multiplication means that this will multiply on this side and this will multiply on this side. So this will give us 3x plus 4 times x plus 2 equal to 7 times x square plus 3x plus 2, and this time if we multiply 3x with x, that would give us 3x square plus 3x times 2 will be 6x plus 4 times x would be 4x plus 4 times 2 would be plus 8 equal to 7x squared plus 21x plus 14. And now we are going to bring everything on one side. So transferring everything else, let's write down one more time to make it like 10x plus 8. 10x plus 8 equal to 7x squared plus 21x plus 14. And if we move everything to the left, here will be 0 left on the left side. That will give us 7x squared minus 3x squared plus 21x minus 10x and plus 14 minus 8, and it's already written it is equal to 0. So this gives us 4x squared, 4x squared plus 11x and plus 6 equal to 0. To begin with, this equation was not a quadratic equation. It didn't look like that was a quadratic equation, but you can see that upon simplification, the long story short is that do the simplification whichever way you do, at the end of the day you will have one term involving x squared, other with x, and one will be constant. And now comparing with ax squared plus bx plus c equal to 0, we will have a equal to 4, b is equal to 11, and c equal to 6. If these are the values, and now find the product AC, and this is equal to 4 times 6, which is equal to plus 24. Therefore, we find two such factors of plus 24 whose sum is equal to 11. Remember, so let's find out factors of 24. The factors of 24, if this number is bigger, can be done by small division. 2 times 12 and 2 times 6, 6, and this is 3, and this is 3 times 1. Okay, the 24 has factors 1 times 24, but we cannot take it. The reason they don't add up to 11. And we also have many other factors, but let's only take those factors whose sum is equal to 11. And what about 3 times 8? These are two such factors of 24 whose sum is equal to 11. So therefore we are going to write this equation as 4x squared plus 11x plus 6. So 4x squared plus 11x plus 6 equal to 0. That was the equation, could be written in the form 4x squared plus, instead of writing 11, we'll write 3 plus 8 x plus 6 equal to 0. This gives us 4x squared plus 3x plus 8x plus 6 equal to 0. This means we take common, which is x only, and here we have 4x plus 3 plus, we can take common 2, and this gives us 4x. Sorry, this is 4x plus 3 equal to 0. So if we take common 4x plus 3, that would be 4x plus 3 times x plus 2. This product is equal to 0. Since the product of two real numbers is only 0, if 4x plus 3 is equal to 0, or x plus 2 is equal to 0. If 4x plus 3 is equal to 0, here we get x is equal to minus 3 over 4, and here we get x equal to minus 2. And these are the two possible solutions for the given quadratic equation, and this technique can be used in almost every case, but in next lesson we will use another technique, which is by completing the square.